If you have ever used Google Maps while traveling from Mumbai to Pune, or if you were trekking in the Himachal, you would have noticed something strange. Even if you switch your phone to airplane mode, the blue dot still often knows exactly where you are. No Wi-Fi, no SIM card, no mobile data. Yet, somehow, it still finds you. So what on earth is happening here? How is your phone tracking your location with no internet connection at all? And what is going on behind that tiny blue dot that we never think about? It turns out that the answer is way more fascinating and way more high-tech than most people realize. Because your phone is communicating quietly with some of the most precise machines ever built, sitting 20,000 kilometers above your head. My name is Nimesh, and today, let's decode. Chapter 1: The Network in the Sky. High above the Earth, about 20,200 kilometers away, there are at least 24 GPS satellites that are orbiting the planet. This group is called as the GPS constellation, and it's arranged in a manner so that wherever you are standing, be it Mumbai, Delhi, or the Everest, your phone can see at least 4 satellites in the sky at any moment. Now, here's where it gets interesting. Each of these satellites carry a super precise clock, so accurate that even a tiny error would throw off your location by kilometers. And every single second, they broadcast radio signals towards Earth. These signals contain 2 critical pieces of data. They are precise current time and their exact location in space. And just to be clear, these signals aren't anything fancy like 5G. They are simply radio waves. They travel at the speed of light, about 300,000 kilometers per second. That means they can reach your phone in less than a blink. So, your phone isn't talking to them, it's simply listening. Passively. And that alone is enough to pinpoint where you are. Chapter 2: Measuring Distance Using Time. Here is the genius of GPS. Because these radio signals travel at the speed of light, if your phone can know how long the signal took to reach it, it can calculate how far away the satellite is. As we all know, distance is speed multiplied with time. So, if it took a signal 0.07 seconds to reach your phone, multiply that with the speed of light. That satellite is about 21,000 kilometers away. Now, your phone does this with several satellites. Each distance measurement is like drawing a sphere around each satellite, because the phone could be anywhere along that sphere. Where those spheres intersect, that is your location. Think of it like this. Imagine you're standing somewhere in your city. Someone tells you you're 5 kilometers away from the railway station. That puts you somewhere on a circle around it. Another person says you're 3 kilometers from the market. Now you're at one of the 2 points where the circles meet. A third person now confirms you're 2 kilometers from the mall. Boom, your exact spot is found. That's basically how GPS works. This mathematical process is called trilateration. It's like narrowing down your location by measuring distances from multiple points, not angles. With 3 satellites, theoretically, you would get 2 possible intersection points. Only one of them is near Earth's surface, so we can narrow it down. But there's still another problem. Your phone's internal clock is nowhere as precise as the super accurate clocks on the satellites. Even a tiny time mismatch creates huge distance errors. So, GPS uses a 4th satellite to solve this 4th unknown, your clock error. Together, these 4 signals let your phone solve for latitude, longitude, altitude, and time. That is the clock correction. And that's the why behind needing at least 4 satellites. Without the 4, the math simply doesn't lock in. Chapter 3: GPS works without internet. Here's why. Here is the biggest misunderstanding most people have. Your phone does not need cell towers, data, or a Wi-Fi connection to determine its location. GPS signals are one way, from the satellite to the receiver. Your phone only listens. It never transmits anything back to the satellites. And here's the best part. GPS uses zero mobile data. None. The satellites are like radio stations. They freely broadcast and your phone simply listens. This means GPS works in airplane modes, GPS works in the middle of oceans. GPS works in the mountains. GPS is completely free and public. Whether you have a mobile data or not, whether you have a SIM card or not, makes no difference. The satellites are broadcasting to everyone on Earth constantly. So why do people think GPS needs internet? Because many apps require map data to show where you are. The satellite signals only tell your coordinates. Displaying you on a map requires, well, a map. Apps like Google Maps allow you to download maps offline. So once your coordinates are known, the app simply plots the dot on your locally stored maps. No need for internet. That's why airplane mode often shows your location. GPS is independent. Now, there is something called as assisted GPS or AGPS, where your phone downloads the satellite info via network just to speed things up. This isn't required, it just helps you to get a faster initial lock. Even without AGPS, your phone can still determine its location solely from satellite broadcasts. It may take longer to lock on, but it still works. Chapter 4. Let's talk experience. You have probably seen this happen. You step outside, open your map app, and instantly the blue dot appears. This is because your GPS chip already has the time and location information from the satellites. It's constantly listening, even if you're not actively using maps. And here's the most fascinating part. GPS uses zero mobile data. None. The only data you consume is for loading maps, searching for destinations, uploading your location to a service like Ola, Uber, Swiggy, etc. But the actual location fix, the math, that is entirely offline. This is why delivery riders can find your house, why you never get lost in a new city, why your phone knows exactly when you reach home. All of this from satellites you'll never see. This makes GPS an engineering masterpiece. It's a global utility working silently behind the scenes. Free 24/7 for anyone, anywhere. Chapter 5. Why this system works everywhere. Why build at least 24 satellites? Why 20,200 kilometers up? At that altitude, each satellite can see a massive portion of the Earth. Think of it like streetlights placed so perfectly that no matter where you are in the city, you are lit by at least 4 of them. With enough satellites evenly spaced, this system guarantees wherever you are, mountains, desert, city, you will always have 4+ satellites above the horizon. This global redundancy is what gives GPS its reliability. Even if some satellites fail, this system still functions. And of course, other countries have their own systems too. Most modern phones talk to all of them, which makes positioning faster and more accurate than ever before. Final takeaway. So the real magic of GPS comes down to 3 things: a constellation of satellites broadcasting precise time and position, your phone measuring distance using signal travel time, trilateration from at least 4 satellites to resolve latitude, longitude, altitude, and clock error. No internet required, no phone towers required, no mobile data consumed, just physics, math, and super precise clocks. The next time you see that little blue dot, remember, it's powered by machines racing around the Earth at thousands of kilometers per hour, sending signals traveling at the speed of light. So your phone can tell you where you are within a few meters. GPS might feel ordinary today, but underneath, it's one of humanity's most elegant pieces of engineering. Have you ever used offline maps while traveling? Maybe in the mountains or in the areas with no network? Did it work for you? Drop your experience in the comments below. And if you enjoyed this breakdown, please do like this video and don't forget to subscribe for more such deep dives into tech that's working silently in our everyday lives. Take care, and I'll see you in the next one.